In an old TV, back before the days of flat-screen TVs, an electron in the picture tube is accelerated from rest through a potential difference of 5,000 volts. So part A, what is the change in the electric energy of this electron? Well, the electric energy, UE, is equal to the charge times the potential. So in this case, because we're looking at an electron, which has a charge of negative 1.6 times 10 to the negative 19 coulombs, times the potential, which is 5,000 volts. And when you multiply those together, you get an answer of negative 8 times 10 to the 16 joules. For part B, what is the final speed of the electron as a result of this acceleration? So this is just going to be a conservation of energy. We looked before at turning mechanical potential energy into kinetic energy. Now we're looking at turning electric potential energy into kinetic energy. So we'll set up the conservation of energy equation. Ki plus Ui equals Kf plus Uf. And in this equation, the electron starts from rest, so the initial kinetic energy is 0, and it's accelerated through a potential difference of 5,000 volts. So we're just going to say it's going to go from a potential of 0 to a potential of 5,000 volts. So we'll say the initial electric potential energy is 0. So this equation becomes 0 on the left side is equal to the kinetic energy, which is 1/2 mv final squared, plus the electric potential energy, Q times V, which we've already solved for in part A. So if we want to solve this equation for Vf, I'm going to bring the QV over to this side. So negative QV is equal to 1/2 mv final squared, and then to solve for Vf, just multiply by 2, divide by the m, and square rootify it. So Vf is equal to the square root of negative QV over m. And make sure you're differentiating between this V, which is a lowercase v for the speed or velocity, and this V, which is the capital V for the potential. So this is equal to the square root of negative. Now QV combined, we've already solved for earlier in part A, so that's negative 8 times 10 to the 16 divided by the mass of an electron, which is 9.11 times 10 to the negative 31 kilograms. And when you plug all this in, you get an answer of 4.19 times 10 to the 7 meters per second.